Ka and Kb. Well, let's look at two generic examples first of all. Let's start with the acid. So the IB likes to have acid as HA. So HA plus water goes to the hydronium ion and its conjugate base. Now don't forget it's equilibrium, so make sure that arrow goes both ways. Now the regular Kc is the equilibrium constant, but we say it's Ka for an acid. So products multiplied together divided by reactants multiplied together. And we can ignore the water. What does the concentration of water mean? No one really knows. And plus water's in a different state to the other three. That's another reason that we could ignore it. So we'll get rid of that. Another way that you might see it, perhaps more commonly, is H plus and A minus over HA. Okay, so that's the generic acid. Let's look at a generic base, B. So add it to water, make sure it's equilibrium, and I'm going to get the hydroxide ion and BH plus. So Kb is the basic dissociation constant, and again that's products divided by reactants, and you can ignore the water. So some examples, let's choose the simplest weak acid that the IB want you to know about, methanoic acid. I'm going to ignore the water because last time nothing really happened. And don't forget, it's not really A minus, it's the conjugate base. So just take an H plus off. And like I said before, I'm going to ignore the water. The IB are okay with ignoring the water, especially with the acids. So Ka, it's products multiplied together, their concentrations divided by the concentration of the reactants. Square brackets means concentration. Let's look at an easy basic example. So let's have the equation for Kb for ammonia. Alrighty, so add it to water. You've really got to add it to water to make it work for the bases. Pop off the hydroxide ion. And once again, products divided by reactants, and ignore the water. It's in a different state. And the trickiest example that I can find for Kb is for phenylamine, which is in the data booklet. So phenylamine plus water, make sure you've got hydroxide ion somewhere, and then whatever's left, the conjugate acid, that's the other thing. So once again, products multiplied together at the top, divided by the concentration of the reactants at the bottom. Ignore the water. No problem.